Welcome to my presentation. This presentation is part of the playlist Indefinite Integrals, More Examples. In this presentation, we will be looking at some indefinite integral example problems. Let us look at an example problem related to a polynomial function. Let us evaluate this indefinite integral 4z cubed plus 3z squared plus 2z minus 6 dz. So this is a polynomial function. So the way we can write it out is as follows: y equals to integral 4z cubed plus 3z squared plus 2z minus 6 dz. We can apply this integration process to every one of the terms. So this is the way we can write it. So the first term, integral 4d cubed dz plus integral 3z squared dz plus integral 2z dz minus integral 6 dz. So now if we see any constant terms, we can take it outside of the integration process. So we can rewrite this step as follows: 4 integral z cubed dz plus 3 integral z squared dz plus 2 integral z dz minus 6 integral dz. So now we can apply the integration process, integrating each function separately. We can write this first term as follows: 4 times z to the power of 3 plus 1 divided by 3 plus 1. We are applying the power rule. Let me just pull up the power rule in a minute. So this is how the power rule looks like. If we have y is equal to x to the power of n dx, then when we apply the integration process, this is how the power rule works. X to the power of n plus 1, we're going to take whatever power we have and add 1 to it, divided by the power what we have, n plus 1. So that's the power rule. So let's go back to our example. So when we have 4 integral z cubed dz, when we integrate it, we can write it as 4 times z to the power of, this is n equals to 3 here, 3 plus 1 divided by 3 plus 1, plus 3 times z to the power of 2 plus 1 divided by 2 plus 1, plus 2 times z to the power of 1 plus 1 divided by 1 plus 1, minus 6z. So 6 integral dz converts to 6z plus c, which is a constant of integration. So now we can simplify this some more, and we can write it as 4 times z to the power of 3 plus 1 is equal to z to the power of 4 divided by 3 plus 1 is equal to 4 in the denominator, plus 3 times z to the power of 2 plus 1 is equal to z to the power of 3 divided by, in the denominator we have 2 plus 1 which is equal to 3, plus 2 times z to the power of 1 plus 1 is z to the power equals to 2 divided by, in the denominator we have 1 plus 1 which equals to 2, minus 6z plus c. So if we were to simplify that some more, the 4 and 4 cancels out, we are left with z to the power of 4, plus 3 and 3 cancels out, we are left with 3z cubed, plus 2 and 2 cancels out, we are left with z to the power of 2 minus 6z plus c, where c is the constant of integration. This is the way we're going to apply the integration process when we have a polynomial function. Let's look at another example. Let's say we have another polynomial function which is given to us as follows. We want to evaluate this indefinite integral 16y cubed plus 9y squared minus 6y plus 3 dz. So we can write this one as x equals to integral 16y cubed plus 9y squared minus 6y plus 3 dz. We can apply this integration to every one of the terms inside this parenthesis. So we can write it as integral 16y cubed dy plus integral 9y squared dy minus integral 6y dy plus integral 3 dy. So now if we see any constant terms, we're going to pull it outside of the integration symbol. 16 integral y cubed dy plus 9 is a constant, integral y squared dy minus 6 is a constant, integral y dy plus 3 is a constant, integral dy. Now we are ready to apply the integration process and simplify this. Integral y cubed is in the form of a power rule, so let's recap what we have in the power rule. The power rule is stating that if y is a function of x to the power of n dx, like that, then when we apply the power rule, we can write it out as x to the power of whatever power we have, we're going to add 1 to that divided by whatever we have in the numerator. In the exponential form, we're going to write it as a denominator, n plus 1, like that. So let's go back to our example. And then we're going to apply this here. 16 times y to the power of 3, where n equals to 3 here for us, y to the power of 3 plus 1 divided by 3 plus 1, plus 9 times y to the power of 2 plus 1 divided by 2 plus 1, n equals to 2 in this case for us, minus 6 times y to the power of 1 plus 1 divided by 1 plus 1, plus 3 integral dy is translates to 3y plus c, which is a constant of integration. Let us simplify this some more. So 16 times y to the power of 3 plus 1 translates to y to the power of 4 divided by 3 plus 1 is equal to 4, plus 9 times y to the power of 2 plus 1 translates to y to the power of 3 divided by 2 plus 1 equals to 3, minus 6 times y to the power of 1 plus 1 is y to the power of 2 divided by 1 plus 1, which is equal to 2, plus 3y plus c. So if we were to simplify it some more, 16 divided by 4 is 4, y to the power of 4, plus 9 divided by 3 is 3, y to the power of 3, minus 6 divided by 2 is 3, times y to the power of 2, plus 3y plus c, where c is a constant of integration. So when we have polynomial functions of this kind, where we can integrate each one of the functions separately and then apply the integration process and arrive at our answer. In my next presentation, we will look at some more example problems related to indefinite integrals.